All right, let's dive in. We're looking at Meta AI's LLaMA today. It's their new family of large language models. You sent over these excerpts from their paper, and wow, some of the stuff is pretty mind-blowing, honestly.
Yeah, it's definitely causing a lot of buzz, like all over the AI community.
Well, yeah,
Yeah.
right off the bat, they're saying that their LLaMA 13B model, which is 10 times smaller than GPT-3, actually beats it on most of the benchmarks. Doesn't that seem kind of counterintuitive? I always thought bigger was better with these models.
That's been the trend for sure. But Meta is really focusing on efficiency here with Llama. It's designed to be fast and less resource intensive, especially once it's already been trained, like for practical use.
So you're saying instead of needing a giant supercomputer, you could run this on, like, what, a high-end gaming PC?
Maybe not that simple, but yeah,
Yeah.
you're getting the idea. This focus on efficiency is really important. It makes it way more accessible for, developers and researchers who don't have access to massive computing resources.
Okay, that makes sense. And then there's this other thing that really stood out to me. Llama was trained entirely on publicly available data. That's crazy.
Oh,
Most of the big names doing LLMs are super secretive about that, right?
Oh, absolutely. Using public data sets for a model of this scale is basically unheard of. It's huge for transparency in AI development.
Huge. Okay, so speaking of data, let's talk about what Llama was actually trained on. They used Common Crawl, but they were smart about it. They didn't just take, like, the whole internet. They trained a separate model to filter Common Crawl, picking out high-quality content by identifying pages that were similar to Wikipedia references.
That's clever. Yeah, it's a clever way to deal with all the noise in the internet and extract the valuable information.
Right. It's like training a bloodhound to sniff out the good stuff. But Common Crawl was only like 2/3 of the data they use. They also use C4, which is another web data set, but it was filtered differently. So variety is the spice of life, huh? Even for language models.
Definitely. Exposing the model to a bunch of different sources
Yeah.
helps it learn more nuanced patterns and relationships within the data.
Okay, so we've got the web content, but then they added in code from GitHub, but only open source projects. What was the thinking there? Were they trying to give Llama coding skills?
Probably to help the model understand logic and structure. Code has strict rules and syntax, so it can be a good way to train a model to think systematically.
Interesting. It's like teaching it another language, but a super logical one. Okay, so what else? Wikipedia. And in 20 different languages, too. Does that mean Llama is multilingual? Could it, like, translate between them?
Multilingual capabilities are definitely possible. With that kind of training data, it wouldn't be surprising if they can understand and generate text in multiple languages.
Wow. So imagine feeding it a news article in Spanish and getting a perfect English summary back out. Incredible. Okay, and then they used books. Well, that seems pretty obvious. But they used Gutenberg and Books 3, both deduplicated. Any idea how many books we're talking about?
It's hard to give an exact number, but considering the size of the data sets, it could be millions, easily.
Millions of books. Wow, this is one well-read language model. And they even use scientific papers from Arcs4, but pre-processed to remove all the jargon. So could LLaMA, like, help us understand complex research, summarize a paper or something?
It's definitely possible. By training on scientific papers, LLaMA probably developed a pretty sophisticated understanding of technical language and complex concepts. So it could definitely be valuable for researchers, especially those outside their specific field.
Okay, cool. Now, for something a little more relatable, Stack Exchange. I feel like anyone who's ever Googled a coding problem has ended up on Stack Overflow at some point. So did they basically turn LLaMA into a super-powered Stack Overflow user?
Not exactly, but training on Stack Exchange data should have helped it learn how humans solve problems and communicate technical information.
That's really cool. It's learning from the collective wisdom of the internet. Okay, let's get into some of the more technical details. They did something interesting with tokenization, splitting numbers into digits, and handling unknown characters by byte. Why do it that way?
It's all about efficiency. This method keeps the model size down without sacrificing too much performance. And smaller models are easier and cheaper to train and run.
Right, got to keep things lean and mean.
Right.
Now, let's look at LLaMA's architecture. I know there's some technical jargon here, but what design choices really stand out to you?
Well, they use something called pre-normalization. It helps improve the stability of the model during training.
So it's like making sure the foundation is strong before you build the skyscraper.
Exactly. And they've also opted for the SweetGLU activation function instead of the more typical ReLU. It's getting into the weeds of neural networks, but Basically, SWGLU allows the model to capture more complex relationships in the data.
So they're giving LLaMA a more powerful lens to see the world through.
You could think of it that way. And then there's rotary embeddings, or ROE. It's a new way to encode the position of words in a sentence.
Okay, break that down for me. Why is word position so important, and what makes ROPE so special?
So traditional methods, they kind of treat position as a separate piece of information, just tacked on, basically. But ROPE integrates position directly into the meaning of the words. So it's more intuitive and efficient, for the model to understand context.
Okay, that makes a lot more sense. Now, training a model this big must have taken forever. We're talking about processing a massive amount of data.
Yeah, it's computationally intensive, definitely.
Yeah.
But they did some clever stuff to speed things up. Like they used a specialized attention implementation that uses less memory. And they used a technique called checkpointing, which only saves the important stuff during training.
So they're being strategic about resources, trying to make the training process as efficient as possible.
Exactly. And it worked. They got a speed of 380 tokens per second per GPU. To put that into perspective, they trained their largest model, the 65 billion parameter one, in about 21 days.
21 days. That's actually faster than I would have guessed. Okay, enough of the technical stuff. Let's talk about what really matters. How did LLaMA actually perform? I know they tested it on a ton of benchmarks, right?
Yeah, they ran it through all sorts of tests, and the results were pretty amazing.
Okay, give me the highlights.
Well, let's start with common sense reasoning. On this benchmark called LLaSwag, which tests how well the model can predict the most likely ending to a story, LLaMA 65B actually beat Chinchilla, which is a model with even more parameters.
So bigger isn't always better, even with these language models.
It seems that way.
What about question answering, the tasks that really require understanding information?
Well, on natural questions and trivia QA, which are both closed-book question answering benchmarks, LLaMA 65B did amazingly well, state-of-the-art results.
So it's not just memorizing facts then, it's reasoning and coming up with answers on its own.
Exactly. And what's really cool is that LLaMA 13B, the smaller one, was also really good on these benchmarks, comparable to some much larger models.
Wow, so even with fewer resources, you can still get great results with LLaMA.
Absolutely.
Yeah.
And it doesn't stop there. LLaMA 65B also did incredibly well on reading comprehension. On the RACE benchmark, it was right up there with the biggest and most powerful models.
Amazing. Okay, so we've got common sense, question answering, reading comprehension. What about math? Can it, do my taxes?
Not quite. But it did show some surprising ability in math reasoning on the GSM-8K benchmark, which is focused on middle school level math problems. LLaMA 65B actually beat Minerva, which is a model specifically designed for math.
Hold on. It beat a model specifically made for math, even though LLaMA wasn't. How is that possible?
Yeah. That's what's so remarkable about these large language models. They can generalize their knowledge,
Sure.
and apply it in unexpected ways. It seems that LLaMA learned some serious math skills just from all the text and code it was trained on.
That's incredible. It's it's learning to connect the dots between totally different ideas. What about code generation? Can LLaMA actually write code?
So they tested that
Yeah.
on Human Evil and MBPP. Those are the standard code generation benchmarks.
Right.
And LLaMA didn't dominate this category the way it did in some of the others, but it did perform better than other general purpose language models.
Not replacing programmers anytime soon, but still pretty impressive.
Yeah, and you have to remember, LLaMA wasn't built for code generation specifically, so its performance is actually really good given that.
Okay, what about MMLU? Remind me what that stands for again.
Right, so MLU stands for Massive Multitask Language Understanding. It's a benchmark that covers a ton of different stuff, from, humanities to science and technology. It's basically a test of how much the model knows and understands overall.
Right. So how did LLaMA do on this, ultimate test?
LLaMA 65B did pretty well, but it wasn't at the very top of the leaderboard. It was behind some of the larger models, especially in areas related to academic papers and books.
Which makes sense, given its training data. LLaMA had less of that specific type of content.
So even with less focus on those areas, it was still competitive.
Yeah, very impressive.
You mentioned instruction fine-tuning earlier.
Right.
What is that exactly?
So they took the base LLaMA model and fine-tuned it on instructions specifically, which are basically prompts that tell the model what to do.
Okay. So instead of just feeding it data and seeing what happens, you're giving it more specific guidance.
Exactly. And the crazy thing is, Even a little bit of instruction fine-tuning made a huge difference. On MMLU, it got much closer to the top performers.
Wow. So you're saying these models can actually be taught new tricks?
It seems that way. It really opens up a lot of possibilities for how we use these models, for sure. But, okay, let's take a step back for a sec. What are the, big takeaways here from our deep dive into LLaMA?
Well, I think the biggest one is efficiency. That was a core part of the design right from the start, to be fast and use less resources, to make it more accessible.
Right, and it's kind of mind-blowing, that LLaMA 13b can outperform GPT-3 on so many tasks, even though it's so much smaller. It really challenges that bigger is always better idea.
Totally. And, the fact that it was trained on public data, it's a huge shift for transparency in AI.
Yeah, for sure. It lets way more people experiment with these models.
Okay, and then there's, the performance is just incredible, honestly. Common sense reasoning, question answering, reading comprehension, even math and code generation.
It's a really versatile model with a lot of potential applications.
It's like a Swiss Army knife of language models. You can adapt it to all sorts of tasks.
Yeah, that's a great way to put it. And because it's open, the whole community can keep exploring it and pushing the boundaries. This has been so interesting. It feels like we've only scratched the surface, though. LLaMA is a big deal, It's going to have a huge impact on AI.
Oh, absolutely. It raises so many questions about the future of these models. How will this focus on efficiency and openness? Change how new models are developed? What new applications will we see?
Great questions. I think we'll be thinking about those for a long time. So, to our listener, we hope this deep dive has given you a better sense of what LLaMA is all about, its capabilities and potential impact. This is a complex field, and it's changing so fast, but it's full of possibilities. Keep exploring, keep learning, and we'll catch you on our next deep dive.